In this tutorial, we're going to go through data organization and how to rapidly resort tables of data into something that's manageable that we can work with. And we'll do that in Microsoft Excel using a particular tool known as a pivot table. Now the data that we're going to work from is from this paper here, published in Ecological Monographs, Broad-Scale Geographic Variation in the Organisation of Rocky Intertidal Communities in the Gulf of Maine, authored by Bryson and published in 2014. This paper is rather lengthy, contains huge amounts of data. In particular, we're most interested in the data here, presented in figures 3 and 4, and we're going to attempt to replicate these graphs in Excel. Now, whilst it's biological data, this could be in anything at all. It could be sediment type, it could be distribution of tidal environments, and so on. So we could be doing this in any particular field. Now, this particular paper is fairly useful because they've archived their data onto a website called Data Dryad. So, using the link that I provide, you'll be able to find the particular data on the Dryad website. The particular file that we're interested in is this one here, which is being used to create figures 2, 3 and 4, as well as some appendices and various tables. We'll just download the link by clicking on that file, and you can see the file has downloaded. Locate that file on your computer and open it in Microsoft Excel. You can see my icon here is for Excel. So I'm just going to zoom out slightly so we can just see the major data that we have. I zoom in so we can read some of the titles. We'll see that our data is organized here in rows represent particular sites and particular data. So the first few columns represent the environment, the location of the site, the name, a particular code that people have used, and then an exposure, high or low, and that's wave exposure, which drives biological communities. Then in the latter columns we have some categories that contain either species or physical variables such as bare rock. And as we go along you can see that we have various names of species coming through. Some of them you may recognize. And there's a lot of data in here. If I zoom out slightly, you see that we've got (340) individual samples. These could be quadrats and multiple quadrats and a mean taken and stored in a single row for a single site. But we can see here that for each site we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 quadrats per site. And then these are the values from the quadrats with the level of cover in proportion. So for those of you who don't know what a quadrat is just a square, often made out of PVC plastic, that we can measure the surface cover in a defined area. Many squares are 0.25 meter square, or they can be meter square, 50 centimeter square, so on. It could be a variety of different sizes, and from that we can then extrapolate aerial coverage by just looking at what that content of that particular quadrat is. But it's important that we replicate them. So you can see we've got 10 replicas of each quadrat. So what we're going to do is we're going to use pivot tables to pull out some data that will allow us to compare features and patterns. Okay? And we're going to calculate some particular variables such as standard error from this data. So the first thing that we're going to do is just select, using this icon here in the corner, this small arrow that you can see, allows us to rapidly select all of the data in our dataset. And then we're going to insert pivot table. So we're going to insert, and then we're going to use pivot table. Okay? And you can see that our little help prompt here says it helps you easily arrange and summarize complex data in a pivot table. So we just click that. So this window here asks us several questions. The first one is, what data do you want to put in? And we've already selected it. You can see that this little check mark is just moving along. That indicates that we've already selected that data. And then where do you want the pivot report or pivot table to be placed? We want it in new worksheet. So click OK. So we can see that the screen has changed. We've gone from worksheet 1 to worksheet 2. Okay, so our original data is preserved. We're not manipulating this. We're never going to touch that. We're going to manipulate the pivot table to help us pull out some variable things that we want to figure out, for example. So you can see on the right here, we've got pivot table fields, which have got some options. These are the column titles. So the species, and then the first 5 are our variables of where places are. So the first thing we're going to do is we're going to ask a question. We want to know what's the average cover of Ascophyllum nodosum, which is a species of seaweed, in high and low exposures. So we want row to be exposure. I'm going to drag that exposure into rows. And you can see that my pivot table now contains high and low. If I go back, we've got high exposure, and if I scroll down to the bottom, we've got low exposure. So it's just summarising those 2 particular variables. So the next thing that we're going to do is we're going to add a column in, of values, of Ascophyllum nodosum. So we're going to drag that to values. So we can see here that pivot table now has a count. So we've got a bit of an unbalanced design. We've got 180 quadrats in the high exposed environment. We've got 160 quadrats in the low exposed environment. So we've got a bit of an unbalanced design there. In an ideal world, both would contain 180 or 160. So what we can do now is we can change count into a mean, and we do that by on the values area here, just clicking that drop down and going to value field settings. We click that, it brings up some options here that we can change. So we want average. Click OK. And you can see here that we've got in the high exposure 30% average cover, in the low exposure 84% average cover. So that reflects what we know about this particular species. It's mostly a sheltered shore species, low exposure. You rarely find it in the high exposed environment. So we've now got a mean, but that means very little without having a standard deviation. So we want to add another column here of standard deviation. So we're going to add Ascophyllum again to values by dragging again. And we're going to change the count, value field settings, to standard deviation at stdev. Click OK. We also want the count because we want to know how many quadrats there were, so we just drag that in again. And we've got count. So we now have mean, standard deviation, and a count. So we're now one step closer to actually fully understanding our pattern. So we can take this data and we can put it into a new sheet. Let me just copy it, select it, right click, copy. Using this icon here, new sheet, we'll just add a new worksheet and we can paste it as values. And I just did that by right clicking on my mouse. So just clean it up a bit by changing the titles. So we've now got a neatly organized table here that we can work with. So the final thing that I want to calculate is one of the things that you see on many plots. If we go back to the plot here, you see that we have error bars. Error bars indicate the amount of variability around that mean. And if we scroll to the legend, we see that the means are plus standard error. Okay? So standard error is just a way of summarizing the amount of error that's present within the data. If we type standard error into Google, we find a Wikipedia page, and we can just get the calculation of the standard error from this particular thing here. So standard error is the standard deviation divided by the square root of the number of observations of the sample. So we can achieve this by going equals standard deviation divided by square root, bracket, count, close bracket. And that gives you the standard deviation for that particular, standard error, for that particular species. And if we scroll down again, there's our standard error. So we have a huge amount of samples which are basically controlling this, but we do see a larger standard error for our high exposure data. So we can now plot this really quickly onto a chart. We've done this many times, so I'm not going to explain it too much, but I'm just going to add in a bar chart. So we've got high exposure, low exposure. We've got very, very different means, and we've got the development of a chart here. Okay. I'm just going to add in some manual error bars, which are going to be my standard error. And that's the genesis of that particular chart. So we can see what's happening with respect to the data. So that's how we use a pivot table to reorganize our data to extract just a single species. Now, we're going to move on slightly here. I'm going to go into a more complicated scenario. What I wish to do is to replicate this figure here, figure 3b, which is Ascophyllum cover across different sites. So the first thing is for us to figure out which ones of these is it a site, is it an area, where is it stored, and we're going to work with this to try and replicate figure 3b, okay, in our pivot table. So we'll go back to our pivot table here. What we want are these names, turret, chronology, each point on the x-axis, so we want them to be the row label here. So if that display has gone from the side here, just click on your pivot table and it will come back. I'm just going to remove the fields of the data that we've already simulated, and I'm going to add in site and see what we get from site. See if we can find each point, turret. So we've got them. That's good. If we go back to here, we see that we've got turret, chronology, each point. So we do have more, and that's because figure 3 is wave exposed shards only. So I'm going to add in a filter of exposure, and we're going to select high only. And now we can see that we've now got far fewer particular locations. Our order here might not be exactly the same as the previous, as in the figure here. So don't worry too much about that. But what we'll do is we'll just work our way through to try and replicate this plot somewhat. Okay? So the next one is to add in the values for Ascophyllum cover. So again, we're going to use values here. We've got count, and we're going to make this average. So we now have an average here. We're also going to add in standard deviation, and of course a count. So there we have it. We've now got our data. Point, for some reason, has 20. So let's have a look and see if point is actually in this particular data set. So point's not in there. So we want to remove point from that particular data set. Now it's slightly difficult, so what we'd have to do is just attempt, by clicking on row labels here, attempt to remove it by just turning off point. And there we go. So point might be something that we need to check out within our dataset. Our previous mean might not be correct, so we might need to check out and remove point in subsequent analyses. So we've now got our data. We've got the average. If we look at the plot here, we can see that they seem to have organized it not by alphabetical, but maybe by just changing the order of this from low to high, so we could sort the average of Ascophyllum, smallest to largest. It might give us something that's not too far away from that particular plot. So there's our data. So let's copy this out. New sheet. Pasted text. I'm just going to add a new row in. Right click, insert, site, mean, count, ST, standard deviation, and now we do standard error, which, as we remember, is the standard deviation divided by the square root of the count. And then we're just going to drag this down to match. So, to replicate plot 3b, I'm now going to use a bar chart as we did before. Insert 2D column bar chart. Select data. I'm going to select this icon here. Click all of the sites and the mean. Click OK. I'm now going to start formatting it to clean it up a bit. So the first thing to go, chart title. I'm going to format the axis here to max out our 100 because we're interested in 100%. I'm going to get rid of these grid marks. I'm going to format these. Change the labels to be vertical. Sometimes it takes a slight amount of locating to try and figure out the location of all of these things. There we go. There's some text options. Sometimes you may have to just have a look around, try and find what you're looking for. I'm changing the line to black line. I also want tick marks if I can find where they are. I'm just going to change the break, or attempt to change the break. To match the previous figure. I've finished now by changing the fill of the bars into a black bar. The final thing to add is now error bars, and we'll do that by going to add chart element, error bars, more error bar options, custom, specify value, and then of course we want the standard error calculation that we've just done into both boxes for the above and below bar. And there we have it. A figure that somewhat represents this data here. It looks slightly different because we organized our data using the kind of the high to low of the Ascophyllum cover, rather than some arbitrary way that these have been organized, presumably by spatial location, and I've clustered them somehow. But our figure's not too far away. The only thing remaining is that our bars could be a little bit fatter, just to match this, and we can change this in these options. We can find width, that's of the border. I'm going to try and see gap width here. We want to remove this, make it go down a bit, just to make it a little bit fatter. There we go. Okay, so that's our final plot there. That's how you use pivot tables to reorganize data from what initially looks like a nightmare into something that's a little bit more constrained, and finally into something that's got a huge amount of data within it.